Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. So last episode, we were telling you about the 2022 Winter Classic Invitational Student Cluster Competition. God, we need an acronym for that. And we need a really good one. But we, where we got to, just to like recap things, we talked about the 4 workloads that the student teams were asked to do as part of the competition. And when they were going through each of these things, they had mentors from 4 organizations, one of which was AWS, and then there were a bunch of others, and we'll put their logos up on the screen in a minute. The competition was super interesting because all of these schools had no HPC background and came to the events, without really any. These weren't the universities and schools steeped in HPC history. Big learning experience for all of the people involved. Where we got to was that the fourth step, the fourth challenge in the competition was quite a big deal breaker and leveled the playing field pretty dramatically. Welcome back to Ollie Perks and Evan Bollick from AWS, and Dan Olds from Intersect 360, who was one of the chief wranglers of all of this stuff and got to wear a really, really spiffy yellow jacket.
Yes, that jacket is the envy of the industry now.
It's the envy of possibly the fire protection services. Anyway, there's a fire brigade near you that recommends not wearing those jackets. That's right.
Sam.
Stay away from naked flames when wearing those jackets.
That was big on the label when we received it, so you got to pay attention to that. There was drama at several points in the competition. Maybe the best way to look at that is to kind of look at our leaderboard that we went through as we tracked the competition on our YouTube.
For those who aren't familiar with the student cluster competition, can you just tell us how the teams are made up? How many people are actually sitting behind each of these teams?
Anywhere from 3 to 6 students, typically undergrads. We did have a goodly slug of graduate students, but they paid a penalty because each graduate student, PhD student, would take the slot of 2 regular students. So we leveled the playing field that way. They're all self-recruited to this. I mean, they heard about it from a professor, and they spent their own time on this.
And so we're seeing the scorecard after module 2 at the completion of the second module.
There's a story in here though. Take a look at Tennessee State, who's on top. Did well in LinPack. We had a lot of teams do well in LinPack with scores, 88 points on up. These are all normalized to the top score. Just so you know, that's in every scoring category. But HPCG, this turned out to be their triumph. Tennessee
and
State.
Everybody else's. I mean, that spread the field out, didn't it?
What they did, and this was I get these calls on Sunday, actually during the Super Bowl, from the HPE mentors who are saying, "Hey, we've got a score here that's really out of line." What they did is they reduced the size of the problem and ran it that way. And I'm like, okay. Well, did they run it on 4 nodes? Yeah. Did they run it for the required 30 minutes? Yeah. It's a good score. We didn't make any rules about the problem size has to be a certain size. This is what benchmarkers do.
Right.
And they, schooled the field on HPCG. That was incredible. Then we get to University of Texas, El Paso and the pop quiz. They did very well, but nobody could make up any ground on Tennessee because they pulled in a 96 on this.
Okay, so
take a look.
Moving on. So we hit module 3,
which is NASA with the NASPAR benchmarks, and Tennessee State continues to roll. But what's interesting is that one of the teams that was having some problems early on, Fayetteville State University, and this doesn't show up in this scoreboard, but the NASPAR benchmarks were 3 parts. And Fayetteville had been having problems even at the LINPAC and HPCG part of the competition. So we had BioTeam parachute into them. And in the person of Shane Corder, he pulled them out of the dust, and they achieved one of the highest score on one of the NASPAR segments, which was really cool to see. And that gave them some confidence, and they rolled from there on in.
So you said SEAL Team 6. These guys,
SEAL Team 6.
My team are amazing. What a cool bunch of people.
Ari Berman, the head of BioTeam, has been hugely behind this cluster competition, all in. Anything, he said, anything you guys want or need from us, let me know.
So where we got to again was, Tennessee still being very consistent.
And take a look at the folks trailing through 6th place, 304 for Prairie View. That's tight. There's still another 300 points left out there.
Okay, and so then we go and we discover how painful machine learning can be.
Yes, we do. This threw, as I said in the last broadcast, that this really threw the teams a lot of curves because they hadn't dealt with machine learning before.
OMG, there's a bunch of DNSs there, which I think means something very bad.
Did not submit, could not submit by the end of the week. But there's also 4 100s out there and a 95.
Whoa.
But no one can pick up ground on Tennessee State. But the 100s, again, these are teams that had not seen machine learning. They had a week to learn this from the mentors, and Oak Ridge did great at teaching them about the clusters, which were a different architecture than they'd ever seen before. These were the same architecture as Summit with power chips and GPUs.
And again, that's something really important to call out here. This Summit is a really interesting architecture. It's number 2 on the top 500. And so exposing students to multiple different architectures, environments is really the value of a lot of these phases.
And if I could just take a moment here, we didn't really discuss this in the first podcast, but our goal for this whole competition can be said very simply and briefly, that at the end of this competition, we want students to be able to say in an interview that they have run on 4 different supercomputers, real world codes and benchmarks, and optimize them. That's a
fantastic thing to put on your resume.
Exactly. And they're putting it on their resume. The other thing is that, in my mind, interviews are stories. And you'll always get those questions. What's the biggest technical challenge you overcame? And how did you do it? These kids all have probably 10 or 15 different stories along those lines, and how they worked with a team to overcome them.
We found this with the hackathon that Ollie and I ran last year, with the help of an awful lot of mentors, that the teamwork and the learning and the ability to learn things really rapidly. Those are the things that like as employers we're looking for.
It is time for the AWS Open Foam Challenge. And Evan, you want to talk a little bit about what this was? And
sure. So Dan, just as you said, real world experience and stories to tell. When we first started engaging as a mentor, you raised that same point, and we put our heads together. We came up with Open Foam as a test case. Computational fluid dynamics is a workflow. It's not just a single application, right? And so with Open Foam, there are multiple stages. And for each stage, we wanted the students to consider how to tune the performance, and we wanted them to look for the overall fastest turnaround time in their workflow. And they could do it by any means possible. We just constrained the output physics so that they had to match up on a validated run. We gave them AMD architecture and Intel architecture. We gave them a set of instructions on how to build the application and a rundown on basic differentiators for how they would operate uniquely on AWS versus some of the other clusters that they were in, and how to actually go through the workflow for that OpenFOAM application. And then they went to town and they came up with some really fantastic results. And we've said in some of the previous sessions that are in previous weeks that that for HPCG they reduced the problem size. And I will always tell mentees that the first step in HPC is sometimes to think smarter, not harder. You don't want to just throw more machinery at the problem. You need to rethink how you're approaching the problem. And that was the story that our students told here at AWS, is they literally went through the problem and they thought about it differently. They reduced the dimensionality, they reduced the complexity, the workload that they had to solve, and Prairie View came out way ahead.
Yeah, I mean, that
outstanding time.
Way ahead.
Soaked everybody else.
Yes.
And there is daylight in those numbers.
Oh, there's a whole day and night.
It's a couple of weeks, actually.
Yeah. Well, and that actually got Addison and I discussing this. And actually, when I got the results from Heidi Poxon at AWS on Sunday, I sent an email back and said, is there a decimal point error on this first one?
Yeah.
No, nope. That's what happened. And, they obviously increased the coarseness of the mesh by a lot and ran it the requisite 500 times to make sure the accuracy was the same. And we decided we're going to use our same scoring methodology we have to keep this thing fair. Right. And 100 points to 14 points for the second place, and then 100 points to 8.2 points on the Intel side.
That is,
and they used Tennessee State's trick on HPCG. Tennessee State had experimented along these lines. That's why their scores are double the rest of the field. They didn't go far enough.
Now, when Neil designed this, did he deliberately leave this backdoor in there knowing that it was there?
Yeah,
he did.
Absolutely. And it's common practice in the real world that you're going to reduce the dimensionality and you're going to move the problem along faster as long as you're constrained and satisfying those constraints.
And you're keeping the accuracy at the level that you need.
Yep.
But in our interview with the mentors right after this, the AWS mentors, Neil was practically giggling when we were discussing that part of it. Did you do this intentionally? He's like, oh yeah, I did. Oh yeah. And somebody found it.
He's looking a bit serious there.
This before he got giggling. And by the way, while you have this up, bottom right, I got to recognize Sean Smith. Sean Smith is a former student cluster competition competitor. Yep. I first met him in China at a competition there, and then also saw him in Germany at the ISC competition.
Right.
So that's what got him into this industry.
That is the legacy of student cluster competition. It's
absolutely
building the skills and putting these people in industry.
That's right. And now, and Sean was a software engineer on AWS Batch. He was a software engineer on AWS Parallel Cluster. Now he's a solution architect and working with some of the most interesting customers in the world to build things. He's blazing a trail through the place. There's a career that comes out of this for sure.
That is fantastic to hear.
It is really cool. All right.
Big board, the story the big board
let's get there. So back on the big board, that change, OMG. So Prairie View A&M
went from fifth to second and only behind by 2.21 points out of 600 available. And the next three teams are also pretty close. And there's only 100 points left to get through the interviews. And so Evan, you participated in a bunch of them. What we basically did is we had Addison and myself, and then people from the mentor teams. interview the students. The students presented what they did. And Evan, give us a little sense of what it was like to be on the call for those.
Sure. So they presented the content that, the results from each of the weeks, and they gave us their understanding of the problems that they were solving. So really how much they internalized the work that they were taking on. And then we asked questions to discover, what the workload distribution was, whether they saw the bigger picture, that maybe, HPL and HPCG and the NAS parallel benchmarks are the core kernels, and it shows up again downstream when you're working on full applications like OpenFOAM, and that, it's all sort of related. And they did a wonderful job. I just can't say enough how impressed I am by all of the students, and how much they internalized the high performance computing experience and tool set.
And Evan was great in the interviews, by the way, because he would have this probing question that he would ask, open-ended. So what would you do if you had to optimize another app? He was getting at, have you seen that there are methodologies for doing this?
The methodology that we follow, most of us as solutions architects and engineers for HPC, we do look for the pattern, and we tackle new applications. There are a million different applications, different workloads in HPC, and so you have to think in terms of the commonalities and standard approach, and thinking through modularly, where are you at the micro level, are you at the macro level, and then work your way through from one end to the other.
And I guess you're probably wondering how all of this came out.
So you're telling me that the presentation stage that we just discussed ended up being decisive?
Oh yeah,
and
it was.
And that's interesting. There's another aspect that I want to just call out about the presentation stage. Having knowledge is no good unless you're able to tell people about it.
That's a great point.
Right. That is a soft skill that almost every job, there's jobs like mine where it is my day to day is actually working out how to explain to people what we do and how we do it. But if you think about it a little further, it's intrinsic in every job. It's kind of useless having knowledge if you aren't able to share it. Sharing knowledge is actually what makes the world go round. It tends to also make organizations go round, make companies go round. And super important skill.
Working as a team, that was one of the things that we keyed in on in the interviews. Did everybody learn something? Or was it one person working or two people working and the other kind of looking over their shoulder?
Right.
And that weighed heavily in the scores.
So,
well, Prairie View A&M, they maxed out the interview, 100 points.
Wow.
Ahead of everybody else.
Wow.
So Prairie View A&M was number one. Tennessee State University finished about 30 points back as number two. We had the Texas Tech Red Raiders finish back another 40 or so points as number three.
So our stage ended up being quite decisive, as it turned out.
It was the Hail Mary that Prairie View threw that was complete in the end zone.
Wow, just to use more football-ish
a
analogy.
Three-pointer at the buzzer to get them into overtime. The other thing we did is we also gave away $30,000 in scholarships and in awards to the teams. And that was in honor of Rich Bruckner, who a lot of you will know as the driving force behind Inside HPC before he passed away in 2019. But he was always a big fan of the cluster competitions. You'd see him bouncing around them, and he'd always come up to me because I'm over there interviewing and stuff going, Dan, who do you like? Who's best? Who do you think is going to win this thing? Yeah, come on, tell me. Point me out to him. Go introduce me. Yeah, yeah. He really, it was very close to his heart. So we decided to put a scholarship up for him. And we want to call out HPE for more than doubling the amount that Addison and I put up to where we got to $30,000.
That's fantastic.
Wow.
Kudos to everybody there for doing that, because that is good stuff. And so who won the scholarship? Who won the prize money?
It went to, for most teams, one member of each team. A couple of teams opted to split it up. We also gave a $5,000 award for Morehouse College to help fund their HPC lab, and $2,500 to Cal State Fullerton. There's another award in here that is awarded, but it hasn't been done yet. And I think AWS might play a role in it. We're calling it the HPC Jumpstart Award. And what we're going to do is bend the arms of our sponsors, twist them. And although it won't take much twisting, but get some equipment and some cloud hours out to these schools and have them dedicated to HPC. Because these schools, the majority of them, don't even have a cluster of workstations they can use.
Right.
You know, they're much less cloud hours to use.
We're going to get people to come out and find you.
Please.
If there's other organizations that want to get involved in this and sponsor it, they can come and find you at ISC in a few weeks' time.
Yes.
All of us are pretty easy to find at any time. Come out and find us. Thank you again. Thank you to all of the sponsors, all of the mentors, and thanks to all of the teams that participated in this. God, I hope it.
Yeah.
Look, I hope it has the expected impact on your careers, because you totally deserve it to.
I have resumes from all of those that are looking to get into our industry, and I'm putting those together in a book. The mentors and sponsors get first shot at them, but I will put them up on our website after they've been picked through a bit. But if somebody wants some access to that and is looking to employ some really hardworking, self-motivated, hands-on, knowledgeable students, let me know.
Absolutely. And if anybody else out there has an idea that they'd like to get into this industry and is looking for a bolt hole in, we have, I'm quite literal here, we have dozens and dozens of jobs open in North America and Europe. Work from home, work remote, all sorts of openings. Please just go hit that link at the bottom of the page and come and apply, because our number one constraint as an organization for inventing new stuff is being able to hire smart people. So if we can hire some smart, capable, motivated people, it'll make all of the difference.
Thank you.
Thanks, everybody.
Thank you for the opportunity.
See you all again soon.
Amazing. Thanks.
Thanks, guys.
Bye-bye.
Bye.